colleague and my junior in this department, and the faculty of chemistry department, Lucknow University, students, ladies and gentlemen. So it's indeed my pleasure, my privilege, and I'm a very happy soul today that I'm standing here in front of all of you. Once upon a time I was a student here. I enjoyed, I learned, I fought, I sang songs, I studied, I bunked classes, I did everything that you must be doing now. So what I'm trying to say is that I am a part of you. I am not somebody from outside. I am not somebody from outer space. I am not somebody very serious or a very accomplished person. I am one of you. I have had some experiences in life which I would like to share with you. And as is my habit, I don't carry papers or any prepared speeches or any lectures. I just speak whatever comes to my mind. So again, I'll say that I hope you enjoy my talk. And if you like it, then you can sit back and have a good time. And if you get bored, then you can simply raise your hand and say, "Sir, bahut ho gaya, band kariye." Then I understand, because once upon a time I was also a student, and people would come and give long talks, and we would sit at the back and yawn and get bored. So I don't want you to do all that. Fine. So the topic of today's lecture is, let's see if the pointer is working. It's working. Biopolymers and their applications in food and fabrics. So I am basically an organic chemist. I have been working in ICAR, which is the Indian Council of Agricultural Research. It's under the Ministry of Agriculture, Government of India. Most of you might be familiar with CSIR, Central Drug Research Institute, and IITR and NBRI. But many of you might not be knowing that ICAR is a much bigger organization, much older organization. CSIR might be having maybe 50 to 55 institutes. We have around 110 institutes and 20 universities under our control. But our work is a little specialized, and our institutes are situated a little away from the main cities, because we need a lot of space for our experimental and field researches and experiments. So the common man might not be aware of the Indian Council of Agricultural Research. It was formerly the Imperial Council of Agricultural Research in British times. Now it is ICAR. Even in Lucknow, we have 3 institutes. I don't think you might be aware. One is the Indian Institute of Sugarcane Research, that is in Dilkusha. Another dedicated to fisheries technology. Another dedicated to horticulture sciences. But then again, away from the main domain. So most people in the general streams may not be aware of ICAR or its activities. Now, regarding this topic. So I've been working on this for the past very many years. But I have thought that I will not make it very technical, because you all study from heavy books, you all know what are polymers, you all know what is the chemistry and the technology. So I will try to keep it interesting. I will try to keep it, little chirpy and little interactive. So it's not a classroom kind of thing. It's an interaction between you and me. I will describe some interesting things, some interesting photographs, some interesting work, and I hope that you will enjoy. So what are polymers? You all know what are polymers, but still in the beginning a little introduction is necessary. We all know many more parts. So long chain compounds, I need not repeat, and they've been along for a long time. And as time passes on, as the plastic technology and polymer technology advances and progresses, this field is becoming more and more important. But there's a big parallel field going on, which is the biopolymers. So we are all familiar with plastics and the kind of materials that we see in the markets and all, but there's another parallel group, biopolymers, which most of us are not aware of. We'll talk about that. So again, polymers are of many types. If we classify them, they can be of based on the stereochemistry, or based on whether they're homopolymers or heteropolymers, or maybe condensation polymers or addition polymers. You all know about that. No point in repeating. But again, a little introduction. And then, what is a biopolymer? So a biopolymer, we can say, is a polymeric compound which has a source from either an animal origin or a plant origin. So that description or that definition is not very clear. So let us go into a bit more specific. So this blazer I am wearing, this is again a biopolymer, but we are not aware. The food we are eating, biopolymers, we are not aware. We all know about DNA and RNA. So what are the building blocks of DNA and RNA? and these are all biopolymers. So now, as I go on, that wool is a biopolymer, the starch you eat is a biopolymer, the clothes you wear is a biopolymer. So then it is again becoming a very, very huge subject. So we have to be again specific within the half an hour that I will be giving to you. So what do we do now? We talk about biopolymers which have commercial importance. We will not talk about DNA and RNA and proteins and this and that. We talk about materials which have commercial importance, which have been utilized by the human race for their benefit. Fine? I hope things are clear? Good. Excuse me. So you know that polymers have got certain characteristics. They have got high molecular weights, they have got chain-like structures, they have got three-dimensional structures, they are not linear, they can be crystalline amorphous, they have got a high tensile strength and elasticity depending on their molecular elements, and they have got certain melting and glass transition temperatures. Polymers do not exhibit very sharp melting points, they exhibit a range of melting points, or we call it softening points or glass transition temperature. So these characteristics help in the end applications which the industry develops or which science develops. A huge group of biopolymers which are utilized by the industry, which is utilized by mankind, comes under the domain of the gums and the resins. So these are, as I have listed here, they are from natural sources again, of course. They can be from plant sources, they can be from animals, they can be from fungi, they can be from algae. And the biggest advantage of this is that they seem to be readily biodegradable, because biodegradation is again a very important aspect of today's science, that the materials we generate, the materials we use should be eco-friendly. They should ultimately degrade in nature. They should not remain behind like plastics. So most natural polymers or biopolymers appear to be biodegradable, but not all are biodegradable minded. It is not that every biopolymer is biodegradable. And since they can be extracted from natural sources, we can say that their source is not limited. They are not based on the petroleum sources, so that is self-sustaining. You can keep on growing the animal or breeding the animal or the plant or whatever, and you can keep on extracting the material from them. That source will not end. And most natural polymers are condensation polymers, here listed. And this NRG, or what we call the natural resins and gums, these are a subset of biopolymers and they've got very interesting applications and benefits for the human race. So little chemistry, you see the gums. So gums, if we make a 3D picture, they are like this. They are mostly carbohydrates. They tend to absorb water. They swell. They do not dissolve in water, but they absorb a lot of water. They swell, and they have certain characteristics which make them very, very useful for the food industry specifically. All these gums that I have listed here, these are plant products. They are extracted from plants, and they have got a huge extent of application. And they've got a huge extent of application, especially in the food industry. I'll tell you later. Now resins. So resins, again, we have lots of resins, and resins have got building blocks like this. You see, this is a building block of a resin called lac resin. This is from an insect, and these are the building blocks of lac resin. Straight chain compound called allylic acid, 1915 hexadecanoic acid, and a terpenic acid called basically cellulosic acid. We have another very important resin in the industry that is called rosin, that is extracted from the pine tree. That turpentine smell you get from the pine tree, that is one product from the tree, and this is from the. So these are some of the resins, and the previous one I showed you were the gums. So now let us discuss what is resin, what is gum, what is the difference, what is the similarity. Energy. So we keep it very simple that resins, they have this kind of isoprene, a horse, the organic chemistry people might be knowing, this horse type of structure, the resin has a basic building block of history, and the gum has the building block of a carbohydrate. Fine. So these two, sorry. So these two are chemically different, structurally different. Fine. But they are both biopolymers, and sometimes their uses overlap, sometimes their uses are different. You see, there is no compatibility. Carbohydrates or the gums, they are all water compatible. You can put them in water, they will swell, they will absorb. They might dissolve also to a certain extent. But the resins, these are solvent compatible. They will dissolve in alcoholic solvents, petrochemical solvents, depending on their structure. Fine. So there is absolutely no correlation or relation or connection between the two. But again, they are generally classified in the same group. But chemically, as we all chemists, we know that it makes no sense to club them together, because the kind of chemistry that is involved in this will never match with this. Even if you want to mix the two, they will never mix. They will never form any kind of bond. So chemically they are separate, application wise they are separate, but still for convenience sake we say that this is a group NRG, and NRGs are good, highly applicable in the industry. Now we come to the food factor, that as I was telling, that the foods we eat, the proteins, the carbohydrates, these are all biopolymers. The foods, if it is a proteinaceous food, the building block is the amino acid. If it is a carbohydrate, then the building block is the any kind of carbohydrate moiety. So the carbohydrate is releasing energy on oxidation. The protein is the building block of the human body or the animal body. So the food we use, we eat are biopolymers, but we do not realize. So to go into a little more detail, more complex carbohydrates like cellulose, they have got a huge chain structure and they tend to fold like this. And all woody materials are cellulosic in nature, again biopolymer. So you see that a tree standing in front of you is composed of a biopolymer. You will never realize that, okay, bhai, theek hai, peड़ hai, तना hai, lakdi hai, but is it a biopolymer? But ध्यान नहीं जाता. Again, the protein, the meat, the fish we eat, they are eating biopolymers. You don't realize it. ना हम ध्यान नहीं देते. So when we talk of pure chemistry, atoms and molecules in energy levels and this equation, that equation, fine. So after we do our BSc and MSc and maybe PhD and all, what happens is that you gain a lot of theoretical knowledge. So then a time comes in your career, whether you don't join the bank or you don't join some other job, a time comes in your career that you have to utilize this knowledge that you have learned. So how to utilize, and that utilization can be either academic utilization or applied utilization. Academic means you become a teacher, whatever you have learned about the bonds and the energy levels and structural aspects, you keep on studying and you keep on explaining to students one aspect, that is the pure chemistry, what the universities do. What the research institutes do is we do very little of pure science, we do mostly applied science, that whatever we have learned in our graduation or in our doctorates, we have to apply that for the betterment of society, for the betterment of humanity. कुछ फायदा होना चाहिए, कुछ काम आना चाहिए. Otherwise, simply learning the knowledge will not be of use in a research institute. Research institutes are mostly the applied side. So few applications I will describe, not all, because you will be bored. Few applications, that you have a food and you have a biopolymer. How to apply the biopolymer, how to enhance the taste of your food or the nutritional level of your food. So here chemistry is there, but with chemistry that application is very important. It's not just chemistry of Finar or chemistry of what is given in Boyd or any other book. It is the knowledge that you have, and you have to keep on applying that knowledge, and you have to exhibit, show that okay, you are very innovative, you have developed this product or you have developed this technology, so that the government or the funding agency is happy with you. So very briefly I tell you to make it more interesting. You see all these chocolates and all. So a chocolate has got a tendency to absorb water. So why not give it a coat with a biopolymer? Why not a synthetic polymer? Then the issue of safety will come, issue of toxicity will come. So give it a coat with a biopolymer so that the hydration level is maintained, attack from the fungus is maintained, a gloss is introduced, it makes food more attractive. So you coat the chocolates with a biopolymer. So now I'm coming to the application part. Okay, biopolymer ये होता है, इसके applications क्या है, and in practical value हम रोज देख रहे हैं, but हम realize नहीं करते. I'll give you some interesting examples, so you will get the better picture. Again, the fruits you see, apples and all citrus fruits, a lot of coating is going on to enhance the shelf life. It becomes firm, it becomes shiny, it prevents dehydration, it prevents attack from any fungal element. So you get a better product than what was produced in the fields. The application of a biopolymer. Fine. So we have so many other applications. Coating of fruits and vegetables, because these fruits and shelf life, they have a very poor shelf life. Some start drying, some start losing their color, some start getting a fungal attack. So the produce which is you get from the field and what you get on your table is a hell of a difference, because what you are getting ultimately on the table, that has degraded, that has deteriorated. So we have to keep the deterioration levels at some sort of control mechanism, so that you get a better produce on your table. You get better color, you get a better weight. I'll give you a simple example. Say you take pomegranate. I'm not going into simple examples like this, a brinjal or a parval. I'll give you a fancy example which will be of interest to you. One problem came to us from Assam, right? So they have got a lot of cultivation of ginger. So let us do some mathematics with ginger. Ginger loses water very fast. So within 3 days, it loses around 10% of its water content. So what happens? Now let us do a little mathematics. You have, say, 100 kilo of ginger you have bought for your shop. Fine. You store it in the shelf or the display, 100 kgs. Now within 3 to 4 days, it loses 10% of its water content. So that 100 kg becomes 20 kg. हुआ ना? So बैठे बैठे आपको लॉस हो रहा है. Without doing anything, आपका 100 किलो तो 90 किलो हो गया या 10 किलो तो गायब हो गए. अब क्या करें? Simple thing. Now when you talk in tons, supposing if you have 100 tons, that 100 tons becoming 90 tons, ये क्या हो गया? And I'm talking of 3 days. Supposing it is stored for a week, then maybe that 100 tons is becoming 60 tons. So just sitting and doing nothing, you are facing losses. तो क्या करें? So somehow you have to prevent the dehydration of ginger, अदरक. कितनी सिंपल सी चीज़ है. ये साइंटिस्ट यहाँ खड़ा है, कैसी बातें कर रहे हैं. हम लोग केमिस्ट्री के लोग हैं, ये अदरक और मसाला इसकी बातें कर रहे हैं. बेकार सी बात है ना. लेकिन थोड़ा प्रैक्टिकल आप देखिए. ये अगर हम 100 किलो का आपको प्रोडक्ट हमने दुकान में लगाया और वो 70 किलो बन जा रहा है बैठे बैठे बिना बिके, तो यार आप तो गए काम से. तो कुछ तो करना पड़ेगा ना. So here what the scientist does, he doesn't do any rocket science. He applies chemistry, he applies his knowledge of biopolymers, and he tries to control. So if it is a very small thing like maybe a tomato, 10 rupees kg, ठीक है? तो 10 rupees kg become 10 rupees kg आपका 100 kg है. लॉस हुआ भी तो उतना नहीं हुआ. लेकिन जिंजर इज वेरी एक्सपेंसिव. वेरी एक्सपेंसिव फ्रूट इज लाइक पोमोग्रेनेट. मे बी समटाइम्स इट इज शूटिंग अप टू 400 रुपीज अ किलो. अगर उसका 10% गायब हो गया, 20% गायब हो गया, तो इट इज अ ह्यूज लॉस, स्पेशली इन द एक्सपोर्ट मार्केट्स. सो दिस सॉर्ट ऑफ इंटरवेंशंस आर गुड फॉर वेरी एक्सपेंसिव प्रोडक्ट्स, बिकॉज अगर आपका 10 रुपीज़ का एक मटीरियल है, उसका आपने दाम बढ़ा दिया, 1 रुपया हो गया तो 11 रुपये हो गया, तो फर्क नहीं पड़ता. लेकिन अगर आपका 400 रुपये है और 400 रुपये को आपने 20 रुपीज़ का इंटरवेंशन किया, 420 रुपये हो गया. सो इट इज़ अ ह्यूज नाउ बेनिफिट, बिकॉज कंपेयर टू 400 रुपीज़, 20 रुपीज़ नथिंग. So we do this kind of interventions using biopolymers in the case of expensive fruits, vegetables, not the sasta ones like bangan or tomato. These I am showing just to make it simple for you. But the actual practical application is in the case of very expensive produce. Now we were talking of biopolymers, application of biopolymers in chocolates or maybe on eggs or fruits or vegetables. Now let us talk of biopolymers in other food sectors. The application of gums. So those we discussed were the resins, not the gums. Now I'll tell you very simple things which you never might have realized, but today you will come to know. आप लोगों ने बहुत लोगों ने बियर पिया होगा, आप मानोगे नहीं लेकिन ज़रूर पिया होगा. तो no, the beer is hazy. That beer is never clear. आपने कभी notice किया है? When you pour it in the glass, that beer is having some bubbles and it is hazy. पानी की तरह clear नहीं होता. Why? Because अगर पानी की तरह clear हो, आप खुद नहीं पीना चाहोगे. So there are certain additives, and those additives are biopolymer, a gum which is added to the beer. That gum gives two benefits. It gives that haze to the beer, and it prevents the rapid expelling or loss of carbon dioxide which is dissolved in the beer. Because under pressure carbon dioxide is dissolved. Once the pressure is gone, the carbon dioxide erupts out. So आपको उस carbon dioxide के expulsion को control करना है और थोड़ा एक hazy look देना है beer को. Here it comes the role of biopolymer. ठीक है? A gum. चलिए एक और आपको एग्जाम्पल देता हूँ. मैं ये नहीं दे, मैं अपने माइंड से बोल रहा हूँ. ये तो जो है आप सूप लाइक करते हैं. You want a thick soup. You know, पतला सूप में मज़ा नहीं आता. So you add a biopolymer, a gum, that soup becomes thick. Why? Because these biopolymers, these gums, they absorb water, they thicken. So they act as thickeners. So एक food जो है thickens. You like a thick soup, not a thin watery soup. आइसक्रीम. आप घर में बनाइए आइसक्रीम, दूध को लीजिए, चीनी में मिलाइए, फ्लेवर डालिए, एसेंस डालिए, फ्रीजर में डाल दीजिए. आइसक्रीम बनता है? नहीं बनता है. पत्थर की तरह बन जाएगा. यार ये क्या हो गया? आइसक्रीम घर में आप नहीं बना सकते. Why? Because the commercial ice cream has these additives, these gums. These gums make the ice cream softer, fluffier. आप उस घर में नहीं कर सकते उसको. So what I'm trying to emphasize, very practical, homely examples I'm giving, that very minimal addition of a gum, 2%, 1%, 0.5%, it is giving this kind of effect, जो कि आपके प्रोडक्ट का कमर्शियल वैल्यू को इनहेंस करता है, बढ़ाता है. सी इन द केस ऑफ फूड्स, विजुअल अपील इज वेरी इंपॉर्टेंट. आप लोग बोर तो नहीं हो रहे ना? नहीं, बोर नहीं हो रहे ना? बोर मत होइए. हो गए तो हाथ उठाइए. सर बहुत हो गया. सी इन द केस ऑफ फूड्स, हम रोज खाना खाते हैं ना 3 बार. विजुअल अपील इज वेरी इंपॉर्टेंट. टेस्ट बात की बात है. टेस्ट, खुशबू, प्राइस, जो भी सप्लाई सेकेंडरी है. पहले तो आप उसको देखोगे. अगर आप उसको देख के यू गेट इरिटेटेड और यू डोंट अट्रैक्टेड टुवर्ड्स इट, आप नहीं खाओगे. अब मैं आपको 2-3 बड़ी मज़ेदार चीज़ें बताता हूँ. आप बाजार गए टमाटर खरीदने, आप क्या करोगे? सुंदर सुंदर गोल गोल टमाटर खरीदोगे ना, गोल गोल सुंदर सुंदर. बैंगन खरीदने गए, सुंदर सुंदर चमकीले वाले. आपने कभी सोचा है कि आप जब घर जाओगे तो आप तो उसको काट दोगे, तो अगर वो टेढ़ा भी था या वो परफेक्टली स्फेरिकल भी था, हाउ इट मेक्स अ डिफरेंस. और जो सुंदर वाला है इट्स कॉस्टिंग 50 रुपीज़ अ किलो, जो टेढ़ा मेढ़ा है इट इज़ कॉस्टिंग 30 रुपीज़ अ किलो. लेकिन आपने ब्यूटीफुल ले लिया क्योंकि विजुअल इज इम्पॉर्टेंट. आपने बिना सोचे ये सुंदर, कुछ सुंदर उंदर नहीं है, उसका न्यूट्रिशनल वैल्यू सेम है. काटने के बाद, पकने के बाद एक भी सेम. फिर भी आप चाहोगे कि नहीं मैं गोल वाला लूँगा, टेढ़ा वाला नहीं लूँगा. गोभी जो है सुंदर खिला हुआ लूँगा, बड़ा वाला नहीं लूँगा क्योंकि 25 रुपये का 50 रुपये का. 50 वाला अच्छा नहीं है ऐसा. बट वी ऑल गो बाय विजुअल अपील. सो व्हाट आई एम ट्राइंग टू से इज दैट इन द केस ऑफ द फूड सेक्टर, विजुअल अपीयरेंस इज द थिंग. पहले आप उसको देखोगे, उसके बाद न्यूट्रिशन, टेस्ट, जो भी है उसका सैटिस्फैक्टरी फैक्टर बात की बात. ठीक है ना? अब आप कोल्ड ड्रिंक्स पीते हैं, 7 अप हुआ, जो भी है, ऑल आर हीजी. आप देखते हो थोड़े से क्लाउडी टाइप्स ड्यू टू गम्स. तो सूप्स हैं, मीट प्रोडक्ट्स हैं, आप देखते हो प्रोसेस मीट्स आजकल बहुत आते हैं. आपके कोई कबाब्स हैं, सॉसेजेस हैं, हैम है, एक्सेट्रा एक्सेट्रा. तो कभी आप उनका लेबल देखिए. ओके, तो यूल फाइंड एडिटिव्स. इसमें मीट ये है, इसमें प्रिजर्वेटिव है, शुगर है, कॉन्डिमेंट्स है, और कोई गम है. दे विल आइदर गिव द नेम ऑफ द गम or they will give a number of the gum. That number you can see in the directory that what this number is. But it is a gum. Why the gum? Because it is adding to the texture of the food. It is adding to the stability of the food. If it is ice cream, stability की बात है. If it is a meat product, texture की बात है. So you see the application of chemistry. केमिस्ट्री हमने सीखा, उसका कुछ फ़ायदा हो ना, गम्स के बारे में सीखा, बायोपॉलीमर के बारे में सीखा, कुछ फ़ायदा हो ना, यही फ़ायदा है. Practical benefits of chemistry, which many of you will come later in your career. So we have been discussing about food. तो आदमी की ज़रूरतें क्या हैं बेसिकली? वी नो मनोज कुमार की एक बड़ी फेमस पिक्चर थी, रोटी कपड़ा और मकान, है ना. सो रोटी की बात तो हो गई, फूड. अब नाउ वी कम टू कपड़ा एंड मकान. सो देयर इज अनदर कैटेगरी ऑफ बायोपॉलीमर्स विच आर इन द fabrics or the fiber. These are all again biopolymers. ये पहने it is wool biopolymer, silk है, cotton है, again biopolymers. Maybe a proteinaceous biopolymer, maybe a vegetable or a carbohydrate based polymer, but they are biopolymers and we use them without realizing. So which is the top fabric or fiber in the case of apparels, कपड़ों के बारे में? Cotton. So till today cotton has not been substituted. कितने पॉलीमर्स बनते हैं, सिंथेटिक पॉलीमर्स, पेट्रोकेमिकल बेस्ड पॉलीमर्स, बट कॉटन इज कॉटन, है ना. सिल्क इज सिल्क. तो ये कुछ इनकी जो डोमेन्स है ना, दे आर सो स्पेशलाइज्ड. आप यू कैन ट्राई इन द लेबोरेटरी, यू कैन ट्राई इन द इंडस्ट्री, बट दैट सब्स्टिट्यूट विल नेवर बी. कॉटन तो कॉटन ही है, सिल्क तो सिल्क ही. और रेयन कभी कैन नेवर, और पॉलिएस्टर कैन नेवर टेक द प्लेस कॉटन और सिल्क और वूल. आजकल जो ठंड का ज़माना है, टाइम है, we are all wearing jackets and all, mostly composed of synthetic fibers. उनमें वो जाने जो प्योर अंगोरा वूल में है या प्योर जो है पश्मीना में है या लैम में, नहीं, that warmth is not there which is in the natural. So कुछ तो बात है in a biopolymers जो cannot substitute in the laboratory. So we have discussed about food and now we discuss about the kapda. So these fibers, they are extracted from either a vegetable source, maybe a jute plant or a cotton plant, maybe from an animal source, silk or wool, and then they are put to various uses. Again, biopolymers है ये, but we are not realizing. So cotton and apparel, you all know that first it is the fiber, then you make it into a yarn, माने a धागा, and the धागा is woven into a cloth. That cloth may again be a woven cloth or a non-woven cloth, technically नहीं जानूँगा हम. But with this kind of a material ultimately you get and you wear it. Fine. So again it is a कपड़ा. So आपको रोटी है बायोपॉलीमर, आपका कपड़ा है बायोपॉलीमर. So many other applications are there. We will not go to very many details. But as I was saying that the biopolymers, they have certain advantages over synthetic or laboratory made polymers, and that is why even though supply is erratic and price is erratic and so many other quality wise it is also erratic, still if we can afford, then we will prefer a cotton material, we will prefer a pure wool instead of a polyester shirt, rayon shirt, and I think that all you need. अगर पैसे हैं तो buy the best, नहीं है तो चलो कोई. So lot of chemistry. So आप कहोगे सर आप ये बात कर रहे हो इतना अच्छा है and all that. So many benefits, this that. तो why is it कि ये जो सिंथेटिक्स है ये इतने पॉपुलर हैं और ये गवर्नमेंट फोर्स कर रही है कि आप इनको यूज़ करो, यू यूज़ जूट, यू यूज़ कॉटन, यू डोंट यूज़ द पॉलीमर्स, यू डोंट यूज़ द प्लास्टिक्स. ऐसा क्यों? बिकॉज सिंस बायो प्रोडक्ट्स आर सो सुपीरियर इन टर्म्स ऑफ यूज़, इन टर्म्स ऑफ यूटिलिटी, इन टर्म्स ऑफ बायोडिग्रेडेबिलिटी. अगर ये इतने अच्छे थे पीपल टू रश ना कि भाई हम तो यही लेंगे, हम तो सिंथेटिक वाला लेंगे नहीं, लेकिन सिंथेटिक चलता है ना. क्यों चलता है? सो सम ऑफ द फैक्टर्स आई वुड लाइक टू टेल यू. दिस इज नॉट बेसिकली साइंस, बट साइंस एंड कॉमर्स गो टुगेदर. आप आइसोलेशन में काम नहीं कर सकते. सपोजिंग यू डेवलप कैंसर ड्रग विच इज कॉस्टिंग मे बी ₹1 crore, मे बी अ फैंटास्टिक ड्रग बट नोबडी विल टेक इट. सो जो भी आपका प्रोडक्ट हो, दैट शुड हैव अ टेक्नो इकोनॉमिक फिजिबिलिटी, कि उसको आदमी खरीद सके, उसका फ़ायदा उठा सके. आप ऐसा कुछ मत बना दो कि फैंटास्टिक है लेकिन उसका फ़ायदा किसी को नहीं. सो टेक्नो इकोनॉमिक फिजिबिलिटी गोज साइड बाय साइड विद साइंस इन द हायर एट द एमएससी पीएचडी. एट द लेटेस्ट स्टेज यू विल सी कि आप इफ़ यू मेक अ प्रोडक्ट, दैट प्रोडक्ट शुड गो टू द मार्केट. कोई इंडस्ट्री ऐसा प्रोडक्ट नहीं बनाएगा जो कोई खरीदेगा नहीं. और खरीदेगा क्यों? क्योंकि उसके कुछ बेनिफिट्स हैं. अगर अदरवाइज वो नहीं खरीदेगा, चाहे वो कितना भी फैंटास्टिक हो. दिस आई एम ट्राइंग टू से. सो दीज आर सम ऑफ द पॉइंट्स which I would like to आई वुड लाइक टू यू टू कीप इन माइंड, मेरे माइंड में तो है ही, सो दैट यू विल नो व्हाट इज रिसर्च इज ऑल अबाउट. बायोपॉलीमर्स अपनी जगह है, बट what factors affect research other than the end product? So one is supply and demand. So whenever we talk of any biopolymer or bioproduct, naturally we are dependent on a biological source. इतना तो पता ही है. आप में से किसी को अगर नींद आ रही है, आई एम सॉरी फॉर दैट, लेकिन थोड़ा सा आप एक नेचुरल सोर्स पे डिपेंड कर रहे हैं. तो कभी कभी नेचुरल सोर्स में क्या होता है कि क्रॉप फेल हो जाता है, बीमारी आ जाती है, कोई पाला पड़ जाता है, कोई ऐसा फॉग का इशू है, स्नो का इशू है. व्हाट आई एम ट्राइंग टू से इज द सप्लाई इज नॉट कंसिस्टेंट कंपेयर टू अ इंडस्ट्री, अ पॉलीमर इंडस्ट्री, जहाँ पे सप्लाई इज कंसिस्टेंट. आपने एक फैक्ट्री खोला, आपको चाहिए 10 टन ऑफ पॉलीमर एक्स. आपने बताया कि हमको, रिलायंस को बोला कि हमको 10 टन ऑफ पॉलीमर एक्स चाहिए, रिलायंस दे देगा, इस डेट को दे देगा. लेकिन अगर आपको ऐसा पॉलीमर चाहिए जो एक किसान बनाता है, किसान नहीं दे सकता, किसान के हाथ में नहीं है. कभी ठंड है, कभी गर्मी है, कभी फ्लडिंग है, कभी बीमारी है, कभी कीड़े हैं, तो सप्लाई इज नॉट एश्योर्ड. पॉइंट 1. ठीक है. डिमांड, अगर मैं एक फैक्ट्री खोलता हूँ बेस्ड ऑन बायोपॉलीमर कि भाई हम आई नीड बायोपॉलीमर मेरा रेडी हो गया बायोपॉलीमर, लेकिन हमको मिला नहीं. क्यों नहीं मिला? क्योंकि जो सप्लायर है वो होर्डिंग कर रहा है. वो कहता है कि नहीं, इतने दाम में तो मैं नहीं दूंगा, थोड़ा वेट करता हूँ, जब दाम भागेगा तब. ये सब प्रॉब्लम्स दे डू नॉट कम विद द सिंथेटिक पॉलीमर इंडस्ट्रीज और द पेट्रोकेमिकल बेस्ड इंडस्ट्रीज. दे कम विद ऑल दीज नेचुरल प्रोडक्ट्स वेयर द सप्लाई इज फ्लक्चुएटिंग. सो द सप्लाई एंड डिमांड इज ऑलवेज इन क्वेश्चन इन केस ऑफ अ बायोलॉजिकल प्रोडक्ट, इवन दो द बायोलॉजिकल प्रोडक्ट इज सुपीरियर और सपोज टू बी सुपीरियर. स्पेक्स एंड स्टैंडर्ड्स. कोई भी हमारा एक केमिकल, आप जानते हो कि कोई भी एक्सपाइजर केमिकल, उसका एक बॉइलिंग पॉइंट होगा, एक मेल्टिंग पॉइंट होगा, एक ग्लास ट्रांजिशन टेम्परेचर होगा, डिकम्पोजिशन टेम्परेचर होगा, उसके कुछ पैरामीटर्स होंगे, राइट. जब आप आपको कोई रिक्वायरमेंट हो, सपोजिंग यू ओपन एनी काइंड ऑफ इंडस्ट्री, यू नीड द रॉ मटेरियल, यू विल स्पेसिफाई दैट आई नीड दिस काइंड ऑफ रॉ मटेरियल फॉर माई एज ए इनपुट. आपको मिल जाएगा, नो इशूज. कि हमको ये स्पेसिफिक बॉइलिंग पॉइंट चाहिए, ये स्पेसिफिक मेल्टिंग पॉइंट चाहिए, ये इसका रिफ्रैक्टिव इंडेक्स होगा, ये इसका टेंसाइल स्ट्रेंथ होगा, मिल जाएगा. But in case of biological material, इतने specific नहीं होती. You get a range of properties. You get a graph like this. That एक maximum peak होगा, फिर minimum होगा, उसके बीच में भी होगा. So the standard and the specification is not fixed. So हमेशा वेरी करेगा. आज ये है तो कल वो है, इस साल ये है तो उस साल वो है. तो in case of biological material or biopolymer, this issue frequently crops up. Specification and standards, which is not there in the case of a petrochemical based product. Market dynamics. In the case of biological materials, तो आप सब जानते हैं, आटा, दाल, सबकी कीमत अप डाउन होती रहती है. लेकिन in the case of factory built materials, this kind of fluctuation is not there. ये आज आटे का दाम ये तो कल दाम भाग गया, तो आज गेहूँ का दाम ये तो उसका दाम भाग गया. And this दाम भागना इस फार्मर की तो इतनी दिक्कत नहीं आती है. दिस ड्यू टू द मिडिलमैन, जो सप्लाई चेन होता है उसमें होता है. Somebody starts hoarding, somebody starts adulterating, somebody starts mixing Chinese with Indian, with North, with South. ये सब issues market dynamics. The supplier, the middleman, he keeps on watching. अच्छा ऐसा है, okay. गोदाम का जो लास्ट ईयर का माल है वो देते हैं, इस साल का दवा देते हैं. Practical problems. But in the case of synthetics, रिलायंस को आपने दिया, या आपने रोडिया को दिया, या आपने वैम ऑर्गेनिक्स को दिया, जो आप दोगे वो देगा, टाइम से देगा, प्राइस उसका फिक्स्ड होगा, स्टैंडर्ड्स स्पेक्स उसके फिक्स्ड होंगे. बट इन द केस ऑफ फार्मर बेस्ड, इन विच दे आर मिडिल मैन, इन विच दे आर प्रोसेसिंग यूनिट्स, इन विच दे आर स्टोरेज प्रोटोकॉल लाइक FCI एंड ऑल दीज, ऑलवेज दिस काइंड ऑफ प्रॉब्लम विल कम. सो अभी तक मैं ये आप एम्फसाइज कर रहा हूँ, देयर इज अ बायोपॉलीमर, दैट बायोपॉलीमर इज गॉट अ ब्यूटीफुल एप्लीकेशन फील्ड, लेकिन फिर भी आप उसको यूज़ नहीं कर पा रहे बिकॉज ऑफ ऑल दीज हैजर्ड्स. और लास्ट में आपसे कह रहा हूँ, द लास्ट फैक्टर विच इज detrimental to the biopolymer sector is the cost factor. Again I said that from a petrochemical industry product, the cost will not vary. अगर 50 है तो 50 है, इसका कॉस्ट वेरी भी करेगा नेचुरल का, और क्या बोलते हैं, हमेशा एक्सपेंसिव होगा. A cotton shirt will always be expensive than a weaving shirt or a polypropylene shirt or a packaging material. So always the cost is higher, supply problem, standards problem, specification problem, reiteration problem, इतने problems हैं. तो इंडस्ट्री वाला क्या बोलेगा, या माफ करो, मैं गरुड़िया के पास जा रहा हूँ, I will use a packaging material or I will use any material which is based on a petrochemical source, not the farmer source. ठीक है. So despite all these benefits, bio कि साहब इतने beneficial हैं, इतने environmental friendly हैं, unable to push. क्या बोलते हैं, quantity and supply position is also important in the sense that the kind of volumes that are required in a large factory, even that volume might be a problematic for in the supply chain, because उतना supposing your requirement is of 20 tons, 100 tons, 200 tons, उतना natural product आपको मिल ही नहीं सकता. So again issue. So people going for less environmental friendly products and people say भाई आप प्लास्टिक यूज कर रहे हो, आप ये खा रहे हो, वो खराब है, क्योंकि मजबूर है. Simple as that. You have beautiful natural products, but due to all these socio-economic pressures and techno-economic pressures, they fall behind. So we are coming to the end of our talk now, good or bad. So roti kapda और मकान हो गया. So how मकान? Roti kapda तो हो गया. मकान में there are lot of composites you see. This is a composite, this is a composite, this table is a composite. What is a composite? So composite is about basically three constituents. One is a bulking material which adds bulk. जो मोटा है इसका जो इंटीरियर में is a bulking material that gives the bulk to the material. Then there is a adhesive or a bonding material which is holding that bulking material together. अगर आपका एग्रो वेस्ट है या कोई भी पाउडर है, that adhesive will hold that bulking material together. Third component क्या है? A fiber. What is the fiber doing? It is giving a structural strength. अगर आपने सिर्फ पाउडर को चिपका दिया विद एडिसिव, उसका कोई स्ट्रेंथ नहीं है. But you need strength for this kind of a composite or this kind of a composite. So you need to have a fiber which will give structural strength. So three components of a composite, and these composites are all over the market. So these are being used for low cost housing. These are being used for roofing. These are being used for awnings. अभी आपके जोशीमठ में बनने वाला है वो जो disaster management में, again those housings will be based on composite because they are lighter, they are easy to assemble, they are very convenient to get, they are cheap. So आपका मकान भी आ गया, and that fiber is there. Fiber is giving the structural strength. So रोटी कपड़ा मकान तीनों में आपको बायोपॉलीमर मिल रहा है. So this is simply photograph of simple photograph of roti kapda aur makan, that you have clothes, you have composites, housing materials, you have food, you have a soup, you have a meat product, you have a beer, you have clothes, jute, cotton, this, that. So all these things are the contribution of biopolymers in the market, which we do not increase. So with this, I purposely did not do a lot of chemistry. I thought I will give you practical example. इसमें कि आपको मजा आएगा. I have written a book also. Alumnitic acid. Sometimes what happens is biopolymers, you see, they are made of building blocks, right? We do not use the term repeating unit in case of biopolymer. We use the term building block. So what is happening sometimes that the building block is more important than the biopolymer itself. Biopolymer का degrade कर दो या hydrolyze कर दो, and you get the constituents. One of the constituents is more important. So I showed you one slide here. I will go back. This one, fine. So this is a resin, lac resin, which used to have a lot of applications, especially in the polishing industry and the molding industry. And this is composed of two building units. So one is the straight chain compound, which is called alumnic acid, 9-10-16 hexadecanoic acid, and one is the turpenic closure. Now this acid, it is proving to be even more useful than the whole biopolymer. So now the trend is to hydrolyze this and get this and put into various applications, especially in the pharma industry and in the cosmetic industry. Fine. This is called aluminic acid. This is common name. Otherwise, in 1916, hexadecanoic acid. So this one book I have written specifically based on aluminic acid. It's not the main resin, the hydrolysis product of the resin, which you from where you are getting the aluminic acid, and entire book, because so many applications there from prostaglandins to PGRs, plant growth regulators, to perfumery compounds, to cosmetic compounds like your sunscreens. The parent lac may be costing around 1,000 rupees a kilo. Aluminic acid costs about 4,000 a kilo. So it becomes more beneficial to extract the aluminic acid from that original resin and give it a number of applications. Fine. So this book I have written, you will find it useful. I don't know. So I have written some books on Lucknow also, as the lady was saying. So this is my hobby. I write about Lucknow, although I don't stay in Lucknow. So these are some of my books on Lucknow. Maybe you would like to read. And I come from this institute. It's called INFRET. Presently I am posted here. It's called National Institute of National Fiber Engineering and Technology. We celebrated our 85th Foundation Day just a few days back. So that's all, gentlemen, and I hope you enjoyed my talk. Any questions? Most welcome. Thank you.